Okay, this is part 2 of how to heat your hot tub on the cheap, or in my case, make an analog controller. I should tell you that I bought my hot tub, I don't know, 15, 18 years ago or something like that, and I've put like 3 different solid-state controllers in, and they drive me crazy, so I decided to build my own. And before I get going, I should tell you that I am not an electrician, I'm not an engineer. In fact, all I do is I drive a tugboat up and down the coast. But I was very fortunate to grow up on an island off the coast of Maine, and my best friend, who's a nuclear engineer now and teaches at a maritime college, he and I used to have a lot of fun, and his father, Bob, was an amazing, he did everything mechanically that was amazing, but he also had a very good gift of explaining how electricity worked and that sort of stuff. So if you don't know anything about electricity or you have any questions, be very careful. Don't try this yourself unless you're very comfortable with this sort of stuff, because 220 will kill you. It's killed a whole bunch of people, and it could do it to you too. So if you don't know what you're doing, do it. I don't make any warranties or anything. This is what I did. It worked for me. I also had it checked by electricians and marine engineers to make sure that I was doing the right thing. But anyway, being that as it may be, I don't warrant this or anything like that. Do what you want to. I just want to show you how it works. So the first thing I need to tell you is that I have a ground fault interrupt circuit, or GFCI, at the breaker. And this brings in 220. And so with 220 you have L1 and L2, neutral, and a ground. So all this is already protected through a GFCI. L1 basically just goes over and is connected hot to the motor all the time, to the pump. And then, now, well, wait a minute, you know what? What I didn't tell you was that one of the problems that I had was I got a 220 hot water heater for $39 that you can pick up at Lowe's or Home Depot, and this way it would cycle the pump on to go through a heating and cleaning cycle in the morning and the night, and that was fine. The only problem is that this when you use this, it runs on the low side of the pump. But if it happened to be on and you got in the hot tub and turned it on high, it wouldn't switch off. So the high and the low would get power together and burn up your pump at the very least, and do a lot of other damage at the very worst. So we had to do something that was a little different. So basically what I do is I have an air switch here, and the air switch is just so that there is no mechanical connection between you and the electricity. You push a button and it pumps air through a hose, and the air triggers the switch. So that's another safety precaution. Anyway, L1 goes there all the time. It also supplies power to the timer. L2 comes over and puts power over to the switch. What happens is, this is a relay here, a 220 relay with a 110 volt coil here that activates the relay. I obviously have the pump and everything grounded at all time, and then a neutral running over there too. But basically what happens is, when everything's off, the timer has power and has priority. So in other words, the timer will come on, it'll tell the pump to, it'll activate it, and it will send power down, and coming over here like this, come over like that, and since this is normally closed, it's going to go, and the power's going to go right to there. And this one's always going because it's hot all the time. So that will operate that. When that happens, I also have a leg that comes out of here that runs a 120 volt relay that clicks a 12 volt, it just opens and closes a switch to operate my heating element that's also hooked to my thermostat, which is just an analog thermostat. And then I don't show it, but that goes back to the neutral over here. So that when this goes, if the thermostat calls for heat, it'll activate the ozone and the ozonator, and close down for the 24 volt pump for the heating system. But anyway, then if this is going, and you go and you press the button and to activate for the high side of the pump, what happens is it will take power from here, activate the coil will snap up over here, and that will disconnect the low side. It will connect the high side, and you can see the high side has the L2 now goes over to there, and it trips out where the power was coming from here, so that way they can't run at the same time and have big problems. So that's how that works. If you want to see real quick, I'll show you how the systems work over here. If you saw part 1 of my video, some of this will be familiar to you. But basically, let me start over here. This is an ozonator. This is the box that I had originally where I had my thermostat, but I've changed that a little bit. This is the relay that switches over to run to the furnace. This runs over to the furnace, which is basically just opening and closing a circuit so that my taco controller will think that thermostat's turning on. If you look over here, I don't know if you can see it or not, but this is the analog thermostat. And I bought it for $35 online, and there's a million of them on eBay. And basically, it just has a little probe that goes in over here. I just 5200'd that in, and it clicks on and off whenever it needs heat. Coming over here, this is an air switch. Got a couple air switches, and if you see right over here, what I've done is I brought the tubes and I just wrapped it around here, so if any water comes down, it'll drip off of here, not follow its way back to the tube. There's just a little safety thing that I put in there. But anyway, this is my 220 hot water heater controller, and then my relay is all in a watertight box back there. And that's about it. I hope you enjoyed it. Please, if you have any ideas or think it's a good idea, or you think of a better way to do it, please comment me below, subscribe, and like the video. All right, thanks. See ya.